Today you're going to learn about covalent molecules. In grade 10 you might have called them also molecular compounds. So first we're going to go over in general what they are and some properties, and then we're going to spend some time learning how to draw structural diagrams of them. So first thing we need to know, what are covalent compounds? So covalent compounds form from joining two nonmetals together. This is different from an ionic compound. Ionic compounds have a metal and a nonmetal. So two nonmetals joining together make a covalent bond. In a covalent bond, it's a little bit different. When we talk about electrons, they're shared between the two nonmetals, and that's what holds the atoms together. In the ionic compounds, if you remember, metals gave the electrons to the nonmetal. But here, since you have two nonmetals, they're going to share them. What are some properties of covalent compounds? So we used a list of properties to describe ionic compounds. Now we're going to do the same for covalent compounds. First one, if we're talking about state, they can be a solid, a liquid, or a gas at room temperature. This is different from ionic compounds where we said they were solids at room temperature. So covalent compounds can be any of those three states. In comparison, they have lower melting and boiling points. Especially if you already have liquid or gas, they'll be even lower. Ionic had very high, these ones can be lower in general. Most ionic compounds don't dissolve in water. There are some exceptions, but in general they don't. But a good differentiator here is if they do dissolve in water, you'll notice these ones don't conduct electricity. So if they're actually able to dissolve, they won't conduct electricity. If we decided to check their odor, they do have strong or distinctive odors at room temperature. So they would be things that would be easily recognizable. Not all do, but if they do have an odor, it is. And an example you're probably familiar with would be water. There are lots of other things like gases, oxygen gas. They can get even more complicated though. They can be chemical formulas for different things like glucose, which has 6 carbons, 12 hydrogens, and 6 oxygens. So there's quite a variety here with covalent compounds. There are some features to look out for, but it's not as distinctive as ionic. When we talk about ionic compounds, we said that those electrons are shared between the two nonmetals. That's what forms the bond. There are different types of covalent bonds that you can have in covalent molecules. The first one is a single bond. Atoms share one pair of electrons. So two ways of showing that. You can either use two dots, so dots are still electrons, or you can just draw a straight line, and that would be in between two elements. Next one, a double bond. Atoms can share two pairs of electrons. That means 4. If you were doing it with dots, you would put 2 pairs of electrons together. If you're going to represent it with lines, it would be 2 lines. When you see the lines, one line represents 2 electrons. The last one is a triple bond. Triple bonds are where atoms share 3 pairs of electrons. 3 pairs, that means you've got 6. So you would have 6 dots, or you would put 3 lines between your elements. Sometimes in our diagrams we have electrons, but they don't bond with anything. So if that happens, we have something called a lone pair. Electrons that are part of the structure, but they're not actually in a bond. So you just draw two dots and it would sit beside the symbol for the element. So now what we're going to do is learn how to draw these structures. There's a series of steps that are helpful to learn, so we'll walk through those steps and we'll practice a few examples together. If you're not sure about what some of these steps mean, don't worry, we will come back to them and refer to them when we walk through our examples. So the first thing you want to do is determine the total number of valence electrons that must appear in the structure. So we'll go over how to do that next. Next, you have to identify the central atoms and the outer atoms. There's two ways to do that. The central atom should always have the lowest electronegativity value. And you can look up the electronegativity value on your periodic table. The other way of looking at it is the central atom is often the first element in the chemical formula, but there are some exceptions. Also, some other exceptions. One exception is with hydrogen. It can't be the central atom. Even though it might have the lowest electronegativity value, it can't. It only has one electron to bond with, and it can't bond with anything else. Once you've figured out what's going in the center and what's going to be joined to that central atom, you're going to write a skeletal structure. So it's like a bare bones version of the molecule. So you have your central atom, and you're going to join the central atom to the outer atoms using single bonds or 2 electrons. We have to go back and make sure we keep track of our electrons that we have used and what we have left. So for each bond in your skeletal structure, you want to subtract 2 from that total number that are there, and you can see how many more you have to put in your diagram. Step 5, you want to make sure everything has 8 electrons around it. Start with the outer atoms, and then make sure the central atom has 8. There are some exceptions. When you look at the periodic table, what are some exceptions? Hydrogen can only have 2 electrons around it. Beryllium, 4. Boron is 6. Otherwise, we're going to assume 8 for the rest. The last 2 steps may or may not happen, and it depends on your compound. So if after you've done steps 1 to 5, and you look at your central atom and it doesn't have a complete octet, which means it doesn't have 8, so you try and make 8 around everything in step 5, but the one in the center doesn't, then this is where you're going to need to make multiple bonds, multiple covalent bonds, double or triple bonds. And you're going to have to share electrons from lone pairs. Last step, when you're done steps 1 to 5 or 6, then you're going to replace your dots with lines, so it's got a proper bonding structure. So let's take a look and try out some examples, and you can see some different cases for structures. All right, we're going to draw the Lewis symbols and structure for first carbon tetrabromide. So you need to make sure you have a chemical formula for the structure before you start, because you need to know how many atoms of each you have. First step was to try and find the valence electrons. So how do you do it? First, we're going to look at what group carbon is in. So if we go back to our last lesson, carbon is in group 4, which means it has 4 valence electrons. We're going to do the same thing for bromine. Look on your periodic table, and bromine is in group 7. So it has 7 valence electrons. But then we have to check how many atoms we have of each. there's one carbon. So each carbon contributes 4 valence electrons. But there's 4 bromine atoms, so we need to multiply this by 4. So that means 28. 4 plus 28 means I have 32 electrons. Now that I have my total number of electrons, I can go on to step 2. Step 2, we have to figure out what's going in the center and what's going on the outside. So what you can do is look at the electronegativity values of carbon and bromine. Which one is lower? Carbon has a lower electronegativity compared to bromine. So it's going to be the central atom. And bromine will go on the outside. The other way you can look at it, carbon is the first element in the formula, so most of the time that will work. Carbon will be in the center, and then the other ones are joined to it. So this is step 2. You don't necessarily have to write this one down, but you want to do a mental check. Then you're going to start building your skeletal structure. So carbon's going to go in the center, and you have to join each of the outer atoms by 2 electrons to make a single bond. That's the minimum. So 2, there's a bromine. Then we go to this side, 2. There's a bromine, 2. Bromine, 2. Bromine. That's step 3. Write a skeletal structure with outer atoms joined to the central atom by single bonds, 2 electrons. So 2 here, 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 and here. Those are 4 bromines. I've put them all in. Now I need to go to step 4. I want to do a check. How many electrons do I have left? I had 32, but in my diagram here, I've put 2, 4, 6, 8. So what's 32 minus 8? 32 minus 8 is 24. So that means I have 24 electrons to put in my diagram. I've put in 8, I've got 24 more. So now I'm going on to step 5, and I want to try and fill my outer atoms to make sure they have 8 around them. So you can start at any one. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I've used up all 24. Then we're going to check to make sure that there are octets around everything. 8. So 2, 4, 6, 8 around this bromine. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. All of the bromines have 8. Then I look at carbon in the center. Does it have 8? Yes. 2, 4, 6, 8. Any electrons in between 2 symbols are shared between both and count for both. So at this point, I've used up all of my electrons and everything has 8 around it. So I don't need to go on to step 6. That means I can jump right to step 7, and I'm going to try and replace the bonding electrons with lines. So the bonding electrons are the ones that are shared. These ones in here. So I'm not going to leave them as dots. I want to put them in as lines. So what is it going to look like? Carbon, bromine, 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 bromine. And then I'm going to put my lone pairs of electrons still on my diagram. And that's your Lewis structure for carbon tetrabromide. Let's try out another one. Next one we're going to do is the chlorate ion. So you might want to pause the video right now and see if you can try counting the number of valence electrons and figuring out which atom is going to go in the center versus which one's going to go on the outside. And then we'll take up the rest of the question together. If you want to give the whole thing a shot, give it a try and unpause when you're ready to check. So first thing I'm going to do, chlorine. Chlorine's in group 7, so 7 electrons. There's 1, so it's contributing 7 valence electrons. Oxygen, there are 6 valence electrons because it's in group 6. I have 3 of them, so 18. Then I have this -1 charge because it's an ion. -1 means 1 extra electron. So if I have a negative charge, I have to add electrons. If I have a positive charge, I take away. Here I'm adding, so 7 plus 18 plus 1 gives me 26 electrons. Then I'm going to look what's going in the center, what's going on the outside. Chlorine is the first element here. It's going to go in the center. And then I have to join my oxygens to the chlorine like that. And I have to make sure that I put at least 2 dots around it in between each bond. Then this is where my mental check comes in. I had 26. In my diagram, I've put 2, 4, 6. So I have 20 more electrons I need to put in. So you can start at any oxygen. 2, 4, 6, 8, 10, 12, 14, 16, 18. So I filled up all of the spots around the oxygen. I've put in 18, but I had 20. So the other two go around the chlorine. So the last 2, I'm just going to put there. That's 26. So then I'm going to check. Do I have 8 around everything? 8 around this oxygen, here, 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 and I have 8 around chlorine. When you have an ion, there's also one extra step you need to do. And to do that, you need to make sure you put the bracket around it. Just like your Lewis dot diagrams here, you're going to need to do that too. So, chlorine in the center, oxygen, oxygen, oxygen. And let's just get rid of that arrow so it's not in our way. Put your dots around it. Put the bracket. And then I'm going to put the negative charge on the outside. So I have to take that, put in my bonds, and then I need to put a -1 charge on. Let's try one more. Last one we're going to take a look at is carbon dioxide. So again, what I would recommend doing, pause the video here, see if you can do as much as possible, and then when you get stuck or when you're ready to check your answer, unpause and see how you did. So step 1, how many electrons do I have? Carbon, group 4, so 4 electrons, and there's 1. Oxygen, I have it in group 6, so 6 electrons times 2, 12, 4 plus 12 is 16. Then I have to look what's going in the center, what's going on the outside. Carbon comes first and is lower in electronegativity, so it's going to go in the center. So then I start carbon, I have to join my oxygens. We always want to try and spread out our outer atoms around the center atom as evenly as possible. So that's why I put 1 on one side and 1 on the other, gives them lots of space. I've put 1, 2, 3, 4 electrons in. I still have 12 more to go. This is what I'm checking in my head. So I start with the outside. 2, 4, 6, 8, 10, 12. I've put all of my electrons in. Now I need to check that I have 8 around everything. So 2, 4, 6, 8 around oxygen. 2, 4, 6, 8 around this oxygen. But when I check my central atom, there's a problem. There's 2, 4. So here I need more electrons to make 8 around, but I've used them all up. So this is where I would go to step 6 that we haven't talked about yet. Step 6 says if the central atom does not have a complete octet, form multiple covalent bonds, double or triple bonds, using lone pair electrons. So what does that mean? If we don't have any more electrons to put in, we're going to have to borrow them. And you can't borrow them from a bond, but you can borrow them from the outside and just move them around. They're going to be shared a little differently. So I'm going to steal one pair and I'm going to move it in between this carbon and this oxygen. That would give me 2 extra electrons to try and make 8. There's 4, 2 more make 6. I need 2 more electrons, so I'm going to steal them from the other oxygen because they like to do things evenly on both sides if possible. So I'm going to steal 2 from this oxygen and steal 2 from this oxygen, and then that would make 8. But how does it work? When I go and draw my structure, carbon is here, but now I'm going to have 4 dots in between the carbon and the oxygen. And I'm going to keep my other dots for my electrons on the outside, but where they were up here and up here, I won't have any dots anymore. And now if I go and count, do I have 8 around my atoms? 2, 4, 6, 8. There's 8 here. 2, 4, 6, 8. There's 8 here. 2, 4, 6, 8 around the carbon. So it takes care of that problem of lacking 8. Last thing you have to do, replace the lines, replace the dots with lines. So double bond will happen on both sides, and I'm left with my lone pairs there. So there's lots of different ways to represent molecules. These 3 examples should hopefully give you a good idea of a few different scenarios you could run into. So make sure you get lots of practice, work step by step, and hopefully you'll be able to understand soon how to draw those structures for covalent compounds well.